Welcome at Eindhoven University of Technology. Normally this campus would be crowded with 15,000 students, but due to COVID-19, unfortunately, it's empty. And it's the reason that we cannot meet in person here at our campus, which is a pity, of course. At Eindhoven University of Technology, we develop new technology related to the issue matter of digital concrete. Sometimes in isolation, like fundamental research, but mostly here in this region, closely related to the industry. Eventually, all the knowledge that we develop should end up with the industry for reasons of sustainability, higher construction productivity, and a larger degree of freedom in architectural design. Today, we are going to visit a young entrepreneur here in this region. The company is called Vertico.
We are at Vertico in Eindhoven. We develop 3D concrete printing technologies, hardware, software, and printing itself. We specialize in architecture and design and the hardware development. We started 3 years ago with the development in Amersfoort with the companies Heiligers, Van den Kamp, Blueways and De War. And we are an offshoot of that start and have been independent for the last years. I don't have a technical background, but the first time I discovered 3D printing, I wanted to make a small object. I started with plastic printing. I was sold. I was over the moon just to be able to make a tiny little plastic object. I came from the automotive myself, so I had some experience with robotics. And one thing led to another. We started to combine these and I wanted to go bigger and bigger and bigger. So we ended up going into the construction market. And that's why we use these robots now to create these large objects. And that's my role in digital manufacturing, really, to make these big things with an aesthetic element in them. That we started with was a stationary ABB robot. We use this to develop the tech. And we've since mounted another robot on track, on an IRS robotics track, also with ABB. And we are now able to move the entire robot over another length of 6 meters. We also have a smaller robot, which we mounted on a mobile platform, which is used for R&D, which is used for demonstrations. That's what it's available for. And besides these robotic solutions, we've also worked on large gantry solutions together with partner companies to develop the gantry system. So we also sell the gantry system and support the development of gantry systems, but we use robotic systems ourselves in our print facility. So our strength at Vertico is to realize the more difficult projects on an aesthetic and design scale in 3D concrete printing. We have very fine layer detail, we have very fine print results supported by the technology that we developed in-house. So we do the complex projects from the design stage to the translation to code to the realization. But what we also do is we support you as a partner in realizing these designs that you want to develop. So we do a lot of consultancy and R&D for people getting into concrete printing to bring these ideas into realization. So we are absolutely 100% involved in parametricizing of the process. So even in the design, we hoped to be able to realize things that are, for example, your topology optimization or your optimization of your design to start with. Then parametricizing them is a revolution in the construction industry with the digitization as well and the BIM, of course. We want to follow these steps. So we're able to take a parametricized model, directly translate it in, for example, a Rhino program to the code, to the rapid code, to the robot code, and produce in one sweep. Obviously, there's still a long way to go in digitization and in parametricization, but our system is really designed to take this CAD design straight to realization in one loop. So major themes in concrete printing at the moment are obviously sustainability. So we're talking about geopolymer concrete, but also how do we attack rebar, the problem of rebar. So these are major themes which are obviously being addressed at the moment. Two themes that we really focus on, are strong in, are on the design side. The first is the topology optimization. So I'm wholly convinced that in order to optimize this process, we need to optimize the design as well in minimizing, for example, the material to carry the same amount of stress. We've done this in a bridge project, and there are other projects now that are really working on this. So this is a key development that we're seeing. And the second one is a parametricization of the entire industry. So this is a theme in architecture, but also a theme in concrete printing. How do we make the designs that we have parametric in order to really add value and make it easiest for all the stakeholders to be involved in this design process and to keep this digital model from idea to realization, so connecting the entire chain. So it's especially these two last developments that I think are going to be major for the pushing of this technology into the real world. So there's a big discussion, obviously, in concrete printing. Do you print in-house or do you print on the job site? And there's a lot of demand in the market now for solutions on-site to do high-rises, to do building projects, understandable. The big advantage of printing indoors is obviously climate control and control of other factors. So in my opinion, we're still in an R&D phase of this technology in which we need to be indoor to develop the technology to a level that it's safe and that the quality is such that we can bring it to the building site. And then there are other problems to solve. But for the time being, we need to start focusing in-house to develop to the right level. We've currently realized 8 projects. For example, we did a topology optimized bridge with the University of Ghent. But we also did some columns, aesthetically interesting columns that we did for the Dutch Design Week with the TU Eindhoven. We are currently developing a house, but I can't say too much about that right now. And one of the projects that's been realized in Enschede with Saxion is a Voronoi wall, which is a wall with relatively simple concrete printed structures, but designed and stacked in such a way that it becomes a very interesting element. It's been realized inside the garden of a facility, so it's a garden wall of stacked concrete elements. Using the parametric model to make this design resulted in great advantages. So the design was fully made in Rhino and Grasshopper by the designers from Saxion. And this resulted in an excellent use case also for this parametric modeling. What happened is when the final building was built, the wall on one side was 1 meter longer and on the other side 1 meter shorter, which meant the design had to change. And this was a very quick change we could make in the model, which then made all these different sections change their shape slightly, but the code could be immediately generated. So the change management, the throughput time of the change was extremely short. This is an excellent example of how you can speed up the process with parametric design. Then we made these small elements specifically so they would fit on a pallet. These pallets could easily be stacked, put on transport, and brought to location. So this is an example of how to make your life easy in realizing a concrete printing design. Finally, the realization of stacking these elements was partly done by adding grout between the elements and partly done by anchoring them into the wall. So it's these small strategies you can use to make such a project flow much better. In these projects, it's never just one company that realizes them. It's always a consortium or different partners working together. In the process in Enschede, it was, for example, the Saxion Hogeschool, so the university, but also a construction company and ourselves. And usually these projects are realized with the support of the government. So if you're lucky enough to have a good innovation climate facilitated by the government, it is absolutely a place to start in order to get your project running. So definitely build on the subsidies or on the project that are possible in EU or worldwide in your local governments, and then connect, for example, a construction partner, a design partner, and a concrete printing partner to realize these designs. One of the reasons that concrete printing is going to become huge is because there are some very basic economic principles at play. First of all, the added value per worker in the construction industry has not been increasing over the last decades. Using machines like this to automate will improve the added value per worker in the industry. This is crucial. The same thing then applies for safety conditions that will be improved in the sense that we can use these machines to do the more hard labor. So these things are economic principles that are important to keep in mind in the future. What we see happening is that these techniques can be applied to make different things. So housing, are we going to be able to print houses in the future? It's not what I'm focusing on. I know others are. Can we make serial production of housing? Is that really where we're going? Right now, 3D printing is used in all other industries to make unique products. And that's really where our focus is as well, with the added value is for 3D printing, not only in concrete, but in other industries. To make unique products, you can use these robots. Now, we've talked about topology optimization, so the philosophy of really decreasing material and getting organic and biomimicry forms. This is an incredible possibility for concrete printing. At the same time, bringing back unique forms into the built environment. So moving away from your minimalist or brutal kind of architecture that we see in the world right now. We want to bring back some of the aesthetic qualities that we can, using these techniques that don't mind if they make 1,000 different things or one thing over and over again. So the future for me really is in this digital optimization and bringing back this form freedom into the built environment. Don't underestimate the impact of the academic world on this technology right now. Not only is some of the most fundamental research being done at universities and some of the most amazing projects are being created at universities, but the projects that we have realized are almost all done together with a university. Be it in the form of a subsidy that we support them on or in the form of a project that they initiate themselves. One of the things that I would like to say is that we really need you to put the effort into developing these things as you are, and the challenge is for you to bring this information to us. So how can we best access the knowledge that you are developing? So the papers that are being written and the projects that are being developed, the communication of these projects is very much key. So if you develop something in which you are proud and fundamental development in concrete printing, communicate it with the rest of the world, short and sweet, because it's moving really, really, really fast. And find partners like us to push your ideas into realization.